Hello everyone, as a continuation of my lecture series, and I have released already a video in the subject called transmission and distribution, in which I have discussed about the structure of power system. So as a continuation of structure of power system, in this video we will see the as a continuation of structure of power system. Here in this video we will see about the types of loads and what is voltage tolerance and interconnectors. So coming to loads, we might have two types of loads: concentrated loads and distributed loads. So concentrated load is one that acts at a particular point of the distributor. So as shown in the figure, first picture shows the diagram for concentrated load which acts at particular point. And a distributed load, we have two: uniformly distributed load and uniformly varying load. The distributed load is, it may have gradually increased, or the same load continues throughout the point. So this is what we call it as distributed load and concentrated loads. And the next important term is voltage tolerance. So what is this voltage tolerance? So if we are generating some 400 kilovolt of power in a voltage at one generation station, and what it should reach, and when it reach it, we know that we all face losses due to natural calamities. So what is that tolerance value? So as per IE rules, the permissible variation of voltage at the consumer end is up to plus or minus 6%. So in case of low or medium voltage, that is up to 33 kV, the permissible variation of voltage is plus or 6% to plus or minus 9%. So in case of high voltage supply, that is more than 33 kilovolt, the permissible variation of voltage will be more than plus or minus 9%, which depends on the generation voltage. So this is what we call it as voltage tolerance. Next important word is interconnectors. So connectors, we all know that connecting two parts or two ends or two supplies. So connection between two or more individual systems that normally operates in synchronism. That is, from a grid, the wind energy is generated, thermal is generated, solar is generated, but the generated voltage is given in the same supply to satisfy the AC loads. Whatever load we use, either it may be for commercial purpose or domestic purpose, we are going to supply the generated power to the load. So this is what we call it as interconnectors, which is clearly shown in the picture. So what is the benefits of interconnectors? So during peak loads, any area can be fed from the other generating stations. Yeah, if solar is not there, then we can use the supply of hydro, or we can use the supply of thermal, or we can use the supply of wind. So reserve power capacity reduces and efficiency increases. It gives continuity in the supply. So if there is any issue in one supply, but we can supply with the other input, so which gives continuity in the supply, and at last it gives better reliability. So interconnected power system is represented by what? Electrical network, electrical grid, electrical system. So none of the above. Can anyone guess the answer? Advantages of interconnected power system: use of old plants, increase diversity factor, reduce capital and operating cost, all the above. So guess what might be the answer? Transmission. What is EHVAC? Is extra high voltage AC transmission lines. The primary reason that power is transmitted at high voltage is to increase the efficiency. This is the this is the main reason why we go for high voltages. As electricity is transmitted over long distance, there will be energy losses along the way. Yes, obviously, high voltage transmission minimizes the power loss as electricity flows from the one location to the next. So what is the advantages of EHV transmission lines? It is used to carry large amount of power across long distances. So it increases surge impedance. High voltage levels causes lower losses. Transmission efficiency is increased due to lower losses. Lesser conductor material is required at high voltage. So this is the main advantage. And what are all the high VHVAC systems in India? So in India, 400 kV lines, we have 5: Sultanpur to Lucknow, Kanpur to Muradnagar, Koradi to Katwa, Srinagar to Jammu Kashmir, and Obra to Kanpur. So these are the 5 high voltage transmission lines which supplies 400 kV line. Then we have 765 kV lines from Agra, Gwalior, Pichur, Malanpur, and Vindhyachal, Bina, the Nagda. This is the 3 lines which supply 765 kilovolt of transmission power. So, but we have demerits also. So, in everything we have advantages and disadvantages. So, the main disadvantages is corona loss and radio interference. So, what is corona loss? It is due to the ionization property, the phenomenon of ionization of surrounding air. It causes a luminous glow, which hissing noise. So in the picture it is clearly shown. As we are going in through bypass, we can find this type of glow in the transmission line, and that is called as corona effect. And radio interference is the corona loss is greatly influenced by the choice of transmission voltage. If weather conditions are not proper, or there is a radio and TV signals which causes demerits of extra high voltage AC system. These are all causes disturbance to the transmission. And some of the other disturbances are line supports, erection difficulties. So when we work with high voltages, the workmanship is very important because we have to work safe. We have to work safe when we work in transmission lines. In this video, we will have a short recap that I have discussed about what is concentrated and distributed loads, voltage tolerance, interconnectors, and extra high voltage AC transmission lines and high voltage AC transmission lines in India. Thank you.